These two together, what's the GCF in the first group? X squared. So you tried factoring that out. And then what's the GCF in the second one? Which is, right, -2. And then you got stuck because these two things that usually match when we're grouping don't. And so you couldn't go forward. So it kind of seems like you can't factor it at all, but today's lesson is going to help us do that. So today's lesson starts with synthetic division, and I'm going to give you a 0 that works for the expression. And you'll use that 0 to do synthetic division. And then after synthetic division, you get all those numbers on the bottom where the remainder is, and you add the x's back in, that step. At that step, we can factor some more. So that's our goal today, to use synthetic division to break it down so that we can even go further to get all the factors for an expression. So that's what we're doing, and we just have 2 examples, and then we'll be done. And then for the next few days, we're going to be extending this concept a little bit further, because today I'm going to give you a starting point. I'm going to say, oh, the 0 is x equals 2. Use that for your synthetic division. And over the next few days, we'll talk about what to do if I'm not giving you a starting point and you have to come up with your own. So let me get your notes. Mark these things that I've marked. So again, remember what we're doing today is we're given a really long expression. We're going to use synthetic division to begin factoring. It'll help us break it down a little bit. And then we'll factor the remaining quotient, means that step where you add your x's back in. That's what that means, the remaining quotient. And then this note down here is good, to talk about. It says, if a factor shows up more than once, use exponential notation on the factor instead of writing it multiple times. Here's what that means. Let's say you factor stuff. Math, you have all these factors. If one of them repeats, like for example, you have 2x plus 1s, we're going to practice writing it like this. Okay, x plus 1 squared, instead of just repeating it. And I'm really not going to count off if you don't do that, because you're not technically wrong, but there's a few benefits to that. One is it just looks nicer. But the second benefit is when we start graphing, especially when we come back from Christmas and we graph polynomials, this makes it really clear that you have a multiplicity of 2. You've probably heard that word before, multiplicity. A multiplicity of 2 means that this 0, the graph bounces. And so it's helpful to write it like this instead of having them all spread out, because it's just a good indicator. So here's our first example. This is the problem from the warm-up, okay, that we couldn't factor by grouping, but we've been given this additional piece of information. X equals 2, okay? That is a 0. That means if you plugged it in, it would give you 0 for the answer. If you did synthetic division with this, what would your remainder be? 0, right? And so the day's lesson is called factoring using the factor theorem. Do you remember a few lessons ago when we did synthetic division and the answers were yes or no only, whether it was a factor or not? Okay, that's the day we learned factor theorem, and so that's what we're using again here, just in a different way. So we begin by setting up our synthetic division. So we know that x equals 2 is a root, or 0. What number do I put in my little box when I'm given this form right here? Positive 2, right? You don't have to change the sign when it's already in 0 form. And is it missing any x terms that we have to put a 0 placeholder for? No. So go ahead and get your synthetic division, and I'll do mine. The remainder should be what, if your math is correct? 0. So if you don't get 0, you've gone rogue, and you need to check yourself out with your partner or with me. So we did our synthetic division. Now we do the next step that says factor the remaining quotient. That's this part down here. When we add our x's back in, what degree do we start with? Right, degree 2, because the problem began with degree 3. So this means x squared minus x minus 12. And I need you to circle this 2 up here. We're not doing anything with it right now, but we need to also not forget about it. It's going to come back in later. So x squared minus x minus 12. Remember, we're not done because we're trying to get this whole thing in factored form. So we have to factor this. What method can we use to factor that? Yeah, with the cross, right? Whether you do it by grouping or swing method, you're going to start either way like this. What multiplies to AC and adds to B? So AC is negative 12, B is negative 1. What two numbers will work here? Negative 4 and 3. If you're doing factoring by grouping, this is where you rewrite the middle term as negative 4x and 3x. If you use swing method, this is where you divide by the a value. But it doesn't change anything because the a was 1. So my two factors from here are x minus 4 and x plus 3. Those are factors because they're being multiplied together. What was the degree on the original problem? 3. That means it has 3 solutions. But these would only give me, this one gives me a solution of 4. This one negative 3. Where am I going to get my third factor from? The 2, right? From the very beginning. This was a 0. This was x equals 2. What is the factored form of that? X minus 2, right? We talked about that yesterday. So if your 0 is positive 2, the factor that gave you that is x minus 2. It's like insiders lie backwards. How come I'm not solving each of those and saying x equals 4, negative 3, and 2? Because I'm not solving. It doesn't say solve anywhere, right? It has some other word, an F word that's completely classroom appropriate. What is that F word? Factor, right? So if it's saying to just factor, you can stop there. If it says solve, you take it one step further and set each of those equal to 0 and solve. Okay. Any questions about this problem? Okay, you try the next one. There's a place in this problem where I'm going to bring our attention back to the board, but I'm going to wait for you all to get there first. So take a few moments and try this. Do you want orange or teal? Teal. Ah, that's what I want too. Can y'all see this lovely color in the back? Parker, can you see this color? All right, so we're not going to forget about that negative 1, right? It comes into play later. You should have had a 0 for your synthetic division. And then when you added your x's back in, what degree did you start with? 3, right? So x cubed plus x squared minus 4x minus 4. This is 4 terms, so you did what after that? What method? Grouping. So the first group has x squared. Now, this is the first mistake that students make, and I want you to, I'm going to put it up here, and you're going to tell me what I did wrong. What's wrong? X plus 1. What did I put instead of plus 1? Nothing. A 0, right? So, because I was thinking this. Oh, look, x squared divided by itself, there's nothing left. So I put nothing. I really wasn't thinking that, but I mean, I kind of was. I was hoping you would think I was thinking that. But what is anything divided by itself equal to? 1. And then same mistake, be careful for the same mistake in the next group, because you divide -4 out of both of those, and still leaves you with +1 there. And then what do both of those groups have in common? X plus 1, thank you. So I'm going to write, that's their GCF, so I divided out of both of those, and then I'm left with x squared minus 4. And we need to talk about this x squared minus 4 for a second and review something. This is not finished being factored. The x squared minus 4 can be broken down more, and you can do that one of two ways. There is the difference of two squares formula that says this. And it applies here because that's a perfect square and 4 is a perfect square. And so using that shortcut gives you this. You take the square root of each of those, you make a minus version and a plus version, right? But if you're not a shortcut liking kind of person, you don't have to remember that shortcut. You can still do the cross method. So this is method 2 for that piece. You can still do the cross. AC, so is -4. What is the B value? 0, right? There is no B value. So it's 0, the number 0. And what multiplies to -4 and adds to 0? -2 and +2. Still the same thing, okay? So -2, +2. And then I have this here. And I feel done. Yes, sir. In a second I will, because I have another x plus 1. Where am I going to get it from? The 0 up here. So the 0 is -1. That means its factor was x plus 1. Okay? So bring that down. And again, if you gave me this, I would give you credit, but I prefer this, the x plus 1 squared. Okay? Questions about that problem? Okay. And we are done for the day.